I'll be giving you a summary about my poster. This is our version of optimal control approach to the problem non-rigid image registration. Okay, we came from a computational geometry background. We're working on the problem grid generation. Okay, we use that background information or techniques as the motivation to the problem of image registration. So let me just point out real quick, then you can view this image on your own. So here versus means the first grid, the composition is actually one transformation, okay? B by itself is the bold grid, and then D1 is another transformation that moves the transformation B to something else, okay? The function composition is together another transformation. Okay, so what it does, the VP, variational principle, what it does is it moves from a given grid to a target grid, so long as you can prescribe the target grid's Jacobian determinant and curl. Well, in this case, we have both given grid, right? We want to see if the transformation would do the job that moves from B to the grid B to grid R. So D1 is the example that moves from the bold grid to the rabbit grid as desired. So versus means here the first transformation is color in red, and that is being superimposed on the black grid on the back. The second one is on the back. It's all color in black. So like this one, for example, this one, if you see some black color being shown on the image, then that means the convergence is not as good as like this one. Okay, so as little as black color is shown, as then it is the better the solution is found. Okay, yeah, that's the idea how you can view all this image. So from our version, we are able to derive its gradient to minimize the functional, to minimize the problem. So we find a reasonable fee in the sense of VP. Okay, as you can see, the constraints are almost the same. Okay, that's actually exact the same. It's just different names. We were able to find the gradient with respect to the control function and the Hessian matrix with respect to the control function, and partial gradient. Partial gradient is in the sense of Jacobian determinant and curl. Okay, little f is the information about Jacobian determinant, and G is the information about curl. Okay, so with this gradient found, we are able to construct different kind of optimizing algorithm, okay, and use that to find our solutions. Here's just two examples, typical classical examples: large deformation in a real data registration problem. Okay, so the first one is a J2V large deformation example, and the second one is the MI brain image example. All right, here's some recorded measurements telling you the convergence is good, and here's some key takeaways and ongoing work that we've been doing. All right, thank you very much.